Hey professionals, my name is Bharat and I'm currently working as a senior cloud engineer for Deloitte Consulting. My core responsibility or my core work the core contribution I do at Deloitte is basically, help adopt and accelerate the client journeys to the cloud. So I'm a cloud migration consultant, cloud modernization consultant, and also a lead of cloud product management, right? So basically, in terms of migrating the 6-star dispositions, and also sort of bringing the workloads from on-prem or from different cloud to a desired cloud, and probably modernizing it to a containerized level, with completely transforming the sort of architecture from monolithic to microservices is my core expertise. And I'm super glad to be in the cloud and cloud technology event. Thanks a lot for everyone. Thanks a lot for the whole team for making me to this, for making me a part of this opportunity. I would love to share my core insight, for which I'm extremely bullish on the next phase of cloud computing. So thank you very much, folks. Let me kickstart my session. So today's webinar is going to be serverless architecture with AWS. In this arena of cloud and DevOps, right? There is this huge buzz about serverless architectures and serverless architectures with AWS, serverless architectures and FAS, function as a service, and also basically you just completely all the serverless applications in AWS GCP, and you have cloud functions in GCP, you have Lambda in AWS, and you have functions in Azure, right? What is this? Is the serverless architecture, the serverless computing is the next phase of cloud computing. So today I'm gonna throw some light on how you can build serverless architecture with Amazon Web Services. So basically, I'm gonna throw some light on the innovations the AWS has and how to leverage those innovations to build a serverless architecture for a 3-tier application or a multi-tier application. So today's agenda or the objective is, I would first explain how to use serverless architecture in a 3-tier applications, and then using AWS Lambda, AWS API Gateway, and other services. So basically, I'm going to explain how to use, how to basically, sort of build a serverless thriving architecture for this microservices and a containerized world with the combination of AWS Lambda, which is the function as a service of AWS, and Amazon API Gateway and other services to implement this whole serverless architecture. And I'll also explain the common patterns for serverless applications. What are the common patterns that are that are basically existing in the software development, and also how I'm going to explain. I'm going to end this webinar with a wonderful case study of how Coca-Cola as a company leveraged AWS stack, that is AWS Lambda, API Gateway, and AWS database services to build a serverless architecture for its vending, for its Coke vending machines, and thereby reducing the cost by 70% and completely completely transforming their whole architecture with heavy reduction of cost and increased agility. Thank you. So yeah, first of all, I would first explain. Take any software application. Every software application or every web app that you use daily, right, is basically composed of 3 components. Now you have a production presentation tier, you have a logic tier, and you have a data tier, right? What is a presentation tier? Presentation tier is basically the UI. For example, if you open Ola app, right, the UI where you can just enter your address, find the nearest cab, right? The outermost layer of any web app or any software through which you can interact, through which a user can directly interact, is nothing but a presentation layer. So a presentation layer consists of the web page, mobile app, UI, etc. Right. So before this, let me at least throw some light on what is multi-tier application. Right. So you keep there's a lot of buzz about what is multi-tier application. Multi-tier, 3-tier, or n-tier has been cornerstone of architecture pattern for decades, right? And it still remains one of the most popular pattern for user-facing applications. Build any user-facing applications, it's a n-tier or a three-tier application. Although the language used to describe a multi-tier architecture varies, a multi-tier architecture generally consists of the following components, and these are the three components. First is presentation, second is logic, and third is data tier. Presentation tier I've already given a glimpse. Let me explain what logic tier is. Logic tier is basically the complete logic. In other words, the source code that's required to translate user actions to an application. For example, if you go to Flipkart, right? If you just tap on tap on a product, and if you just tap on the heart symbol, it gets added to your wish list. So you are basically doing something, and your user actions should get eventually translated to application functionality, right? How do we do that? And your login credential should be entered into a database. How does that happen? All these happens through CRUD database operations and data processing, right? So the whole source code that gets invisible and that helps us to basically transform our user actions to application functionality is nothing but the logic there. And third, of course, data. There's nothing without data, right from the time you log in, there is your user credentials and your name, your age, your gender, your location. Everything has to be properly arranged in data. So as far as data tier is concerned, it's databases, object storage, cache, file system, etc. That whole data relevant to the application, right? So that's how it basically works. And also the multi-tier architecture pattern provides a general framework to ensure decoupled and independently scalable applications. It's no more a monolithic architecture where you completely depend on it. It's a completely decoupled and independently scalable application components that can be separately developed, managed, and maintained, right? As a consequence of this particular pattern, in which the network acts as a boundary. For example, you have to come up with a VPC subnet, and you basically have to build a network for two basic for two basic tiers to communicate. And that's how a multi-tier application often requires many undifferentiated application components. Some of these components include code that defines the message queue for the communication between two tiers, and the code that defines an API and a data model, and eventually a security related code that ensures appropriate access to the application, right? So this is the three-tier or n-tier architecture overview. You have a user-facing applications. Presentation tier is nothing but the web page or the app UI you basically interact with. Logic tier is basically the server where you host your source code. Data tier is where your data tier is nothing but the database or the or basically object storage, where you basically store your information and arrange your data into a right database. That's maybe whether it may be a relational database or non-relational database. This basically sums up the architectural pattern for a simple three-tier application. Now we have to with respect to serverless logic tier, right? First of all, the logic tier of a three-tier application or an n-tier application architecture represents the brain of the application. As I've already told, logic tier represents the brain. It's how you basically converts your user action into application functionality. This is also where the Amazon API gateway, that's nothing but the API service of AWS, and the Amazon Lambda can have the most impact compared to the traditional server-based architecture, right? The features of these two services allows you to build a serverless architecture, serverless applications that's highly scalable, highly available, and secure. In traditional model, your application could require thousands of servers. However, by leveraging Amazon API Gateway and AWS Lambda, you're not responsible for the server management. The server management is completely taken care of by AWS in any capacity. In addition, by using these managed services together, you can gain the following advantages. So what's the only as opposed to the traditional model, right? Opposed to this particular model, the advantages you get is in AWS Lambda, there are no operating systems to choose, secure and patching or managing, no servers to right size, monitor or scale, reduced risk to your cost from over provisioning, reduced risk to your performance from under provisioning, simplified mechanisms to deploy, monitor and secure APIs, improved API performance via caching and content delivery, These are the advantages of the AWS Lambda and the API gateway. One of the striking features of AWS Amazon API gateways, you can completely simplify the mechanism to deploy, monitor, and secure APIs, and you can completely enhance the API performance via caching and content delivery. So now comes the flagship product of AWS, AWS Lambda. What is AWS Lambda? AWS Lambda is nothing but a compute service that allows you to run arbitrary code functions. For example, you have to do a X task. For that, you code, right? And then these are the languages supported for AWS Lambda: Node.js, Python, Ruby, Java, Go, and .NET. For more information, you basically execute it without provisioning, managing, or scaling services, right? What you basically do is you are running an arbitrary code function for a particular task, and you're charged only for that function, and you're charged only when the function gets executed. If the function doesn't get executed, you're not charged, right? So what happens is your business logic goes here, no servers are necessary, your Lambda security and performance at scale, and serverless deployment and management, right? So basically SAM templates specification, SAM command line interface. So this is how things basically work, and this is the and also the most popular use case of Lambda revolve around an event-driven data processing workflow, such as processing files stored in Amazon S3 and Amazon Kinesis. When used in conjunction, Amazon API Gateway and Amazon Lambda function performs functionality of a typical web service, right? It executes code in response to what? In response to an HTTPS request. Amazon API Gateway acts as a front door for your logic tier. Lambda executes the application code. So the API gateway acts as a front door, basically, for your source code to interact with other applications, you use API gateway. But your to execute your source code, you use Amazon Lambda. It's as simple as that. And you can see the Lambda architecture pattern, right? You have the user, and as soon as you go to web, right, there's an HTTPS request generated, and there's an API gateway at the front door, and API gateway is nothing is connected to Amazon Lambda. Amazon Lambda is nothing is connected to Amazon RDS, right? The Amazon RDS lies inside a private subnet, and this complete Amazon Lambda RDS exists inside a VPC. Outside a VPC, we have an API gateway, and the source code will be inside Lambda and gets executed inside the Lambda. And if you want to interact the source code with Amazon API gateway, you do it via this particular service. Now, Amazon API Gateway. Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs. Now, if you write a source code, if you want to convert that into an API or store it, publish it, monitor it, you get a common window where you can do everything from the AWS, and that service is AWS API Gateway. Client, that's us. We that is presentation tier. What we do is we integrate the presentation tiers with the APIs exposed by API gateway using standard HTTPS requests, right? And another important hallmark of API gateways, I repeat again, it's a fully managed service that makes it easy for any developer to create, publish, maintain, monitor, and secure APIs at scale. It also has features and qualities that can add powerful capabilities to your logic tier, right? And another important aspect is its integration with AWS Lambda. First is integration with AWS Lambda, right? An Amazon API gateway REST API is made up of resources and methods. It has a lot of HTTPS methods. A resource is nothing but a logical entity that an app can access through a resource path. A method corresponds to a REST API that is submitted to an API resource, right? And an API gateway allows you to back each method with a Lambda function. That is, when you call an API through HTTPS endpoint exposed in API gateway, when you expose an API HTTPS endpoint and API gateway will basically invoke the Lambda function, right? And of course, you have proxy integrations, right? What is proxy integration? It's nothing but an entire client of HTTPS request sent to a Lambda function, that is source code as it is. AWS API gateway passes the entire client request as an event parameter to the Lambda handler functions, and the output of the Lambda function is returned directly to the client. Again, what is non-proxy? In a non-proxy integration, you can configure how parameters, headers, and body of a client request are passed to an event parameters of a Lambda handler function. Additionally, you can configure how Lambda output is translated back to the user. Even that can be done. And fourth, you have stable API performance across regions. Fifth, you can encourage innovation and reduce overhead with built-in features. You need not add a lot of add-ons. And fourth, you can prioritize API security. There is an inbuilt API security feature that's given in AWS API Gateway that will also, completely will enhance your basically solution and will not let you to go to choose any other application, right? There are three general methods to add authorization to an API in API Gateway. First, you can add authorizations using IAM roles and policies. You can add authorizations to Amazon Cognito user pools, and you can add authorizations to customer authorizers, right? And now we have the data layer, right? As far as the data layer is concerned, serverless data storage options are Amazon S3, Amazon Aurora, Amazon DynamoDB, Amazon TimeStream, Quantum Ledger database, and we have the non-server data storage options such as Amazon RDS, Amazon Redshift, Amazon Elastic Cache, Neptune, and DocumentDB. So with the combination of AWS API Gateway plus Amazon Lambda plus data layer would give you the most enhanced and the most robust serverless architecture to solve all your business problems, and thereby reducing the cost by 80 to 90%. Now let's understand what is a presentation layer. A presentation layer or a presentation tier is another upper layer is responsible for interacting with the logic layer via API gateway. I've already explained what is the presentation layer, right? Presentation layer is nothing but the web page you view through your eyes or the app UI you interact with, right? Now you basically tap something and something happens. So whatever you do, right, that's user actions, and whatever that gets translated is application functionality. For that action to get converted into application functionality, it should be coded. And an API gateway is basically a bridge. A presentation tier is responsible for interacting with logical tier via the API gateway REST endpoints. You will have a REST endpoint through which your presentation layer will interact with your logical tier exposed over the internet. If it's exposed over the internet, using the endpoints of API gateway, you can interact with the source code. And any HTTPS capable client or device can communicate with these endpoints, giving a presentation tier flexibility to take many forms, such as desktop applications, mobile apps, web pages, IoT devices, and so on. Depending on your requirements, your presentation tier can use the following AWS offerings: Amazon Cognito, Amazon S3 with Amazon CloudFront. Now let's go to another important part, sample architecture patterns, right? So what are sample architecture patterns? As far as serverless architectures are concerned, there are three popular sample architecture patterns, that is mobile backend, single page application, and microservices architecture, right? You can implement popular architecture patterns using Amazon API Gateway and Amazon AWS Lambda as your logic tier, right? Now I'm gonna explain the most popular patterns used in current software development. That is the mobile backend, single page application, and also the microservices architecture. Our mobile application, as you can view, right, the mobile application communicates with an API gateway and the Lambda to access the application data. For example, if you have showed your username and password, right, you interact with it and it interacts with the data, right? The pattern can be extended to generic HTTPS clients that are not using serverless AWS resources to run their presentation tier resources. For example, desktop clients, web server running on EC2 instances, and so on, right? Single page application. A single page application hosted in Amazon S3 and Amazon CloudFront communicates with AWS API Gateway and Lambda to access application data. In addition to these two patterns, we discuss the availability of Lambda and API gateway to a general microservices architecture. That is the third sample architecture pattern. First is mobile backend, second is single page SPA, single page architecture, and microservice architecture pattern. A microservice architecture is a popular pattern that, although is not a standard tier architecture, involves decoupling application pattern components and decoupling them as stateless individual units of functionality that communicate with each other. This is basically how it works. So in this mobile backend, right, the presentation layer is the mobile application running on a user device that is on your and you also have third-party providers like Facebook and Google. The client app issues the HTTPS request and includes the tokens from Cognito, you know. And then you have the logic tier, right? Complete logic tier, Amazon gateway with Amazon Lambda. So this architecture shows there are three exposed services. First is tickets, shows, and info. What API gateway does is API gateway endpoints are secured via API Cognito user polls. In this whole method, users sign into Cognito user pools using their 4-head third party if necessary and receive access and token IDs that are used to authorize Amazon gateway calls, right? Each Lambda function, that is the code, is assigned to its own IAM to provide access to appropriate data source. That is appropriate data sources Amazon DynamoDB and Amazon RDS. So Amazon DynamoDB is used for tickets and shows, and Amazon RDS is used to show your information. Amazon RDS credentials from Amazon Secret Manager uses an elastic network interface to access your private subnet. Now let's go to the next important architecture called the single page application. So in this, the presentation layer is a static website hosted in Amazon S3, distributed by CloudFront. So there is a static website that's hosted in the object storage, that is S3, and that's distributed via CloudFront, right? So what Amazon Certificate Manager does is this one. It enables the customs SSL and TTS certificates, TLS certificates to be used, right? And with respect to this whole logic layer, Amazon API gateway with AWS Lambda, the architecture shows three exposed regions. Those are tickets, shows, and info. API gateway endpoints are secured via custom authorizer. In this method, users sign in via third-party identity provider and obtain access and ID tokens. These tokens are included in API gateway. In this API gateway, right? API gateway calls and custom authorizer validates these tokens and generates an IAM policy containing API execution permissions. Each Lambda function is assigned its own IAM role to provide access to appropriate data source. And for Lambda, for tickets, we're using DynamoDB. For shows, we're using Elasticache. And for information, that is, if your name is Shruti and if your age, demography, and everything, to show your customer information, we're using Amazon S3. Last but not the least, let me explain the microservices with Lambda. What is a microservice, right? When did the microservice architecture came into considerance? So Netflix was the first company to implement it. What microservices application architecture means is, before the advent of microservice architecture, there was monolithic architecture where the whole application would be coded using, a single code base, right? But as far as this microservices architecture is concerned, now you basically divide the application into multiple components and you treat each component separately and host each component into a pod. For example, you take e-commerce, Amazon.com as an example. The homepage is a separate microservice architecture. Your wish list is a separate microservice architecture. Your order page, your payment page, everything is a separate microservice architecture, right? So that is how things work. So basically, you divide the application and you create multiple microservice architecture. Microservice architecture 1, 2, 3, 4, right? And in this diagram, you can see there are three microservice architecture in one cloud account, and there's another in another cloud account, right? So it's not bound to a typical three-tier architecture. However, this popular pattern can recognize significant benefits from the use of serverless resources. In this architecture, each of the application components are decoupled and independently decoupled and operated. An API created with Amazon API Gateway and the function subsequently executed by Amazon Lambda is all you need to build a microservice. Your team is free completely to use these services to decouple and fragment your environment to the level of granularity that you desire, because each microservices is completely isolated. Another biggest advantage of microservices architecture is you need not schedule a downtime. You can completely patch and update your application on the fly. In general, a microservice architecture environment can introduce the following capable difficulties. That is, repeated overhead for creating new microservices, issues with my optimizing server density utilization, complexity of learning multiple versions of multiple microservices. You know, and finally, we have the serverless case study, that is Coca-Cola. So what Coca-Cola did is Coca-Cola thought of implementing the serverless architecture into its vending into its basic user vending machines, right? And the way it implemented was a path breaking, right? The fact is, how it works was when you go to a Coke dispenser machine and you order a delicious beverage. This gets, as soon as you order, it gets hit to a payment gateway, and then payment gateway via REST API call. It gets hit a Amazon API gateway, and then API gateway hits a Amazon Lambda where all the logic is handled, and then it sends a push notification to your user. So all these steps happen in 1 seconds, right? So what they did is, as soon as I order for 100 ml of Coke, I get charged $5, and as soon as I pay, it gets the complete process is now written in Amazon Lambda function, and then after I pay and the payment is successful, I get the Coke dispensed into the machine, and then push notification is sent to the user, that is me. This is how Coke completely transformed their architecture using serverless functions, and reduced their cost from 4,500 per year dollars down, down from 1,300 a year. They literally reduced, slashed around 70% of their cost to this point, right? This is how the Coke was successful in probably bringing it down, because one of the biggest advantages of it is, whenever the Coke vending software is not continuously running on a GCE. Whenever I wanna dispense the Coke into a glass, the function gets executed, and only when the function gets executed is when you get billed. That is how it works. So this, in using this complete architecture and strategy, Coke reduced its cost from 4,500 to 1,300 a year using the serverless architecture, which I just now explained. Thank you very much for this wonderful opportunity, Cloud and Loud. I've been admiring you guys for a lot of things, and I also look forward to a lot of your engagement in the future, because you have a cause and you're taking a cause to another level with these wonderful tech sessions. And thank you very much, so that I could share some of my knowledge of the serverless computing, which is nothing but the future of computing. Thank you. This is a very important question. Why and when we need serverless, right? So the fact is, you can't apply the serverless architecture to all the scenarios. For example, if an application is data intensive, then serverless will not, will give you any advantage. For example, there are few things where it's interactive. For example, a for example, if it's if there's a cron job, if you want a job to happen only after, or if you want a job to happen every day at certain amount of time, or daily, once in 3 days, or once in a week, or once in a month, right? Or if you want a customer, or if a customer wants to interact with a particular service of your application, for these less data intensive one task, single task event. For example, the code should do just one task. The function, when I say function, it should do one task. For example, if I click the button, the Coke should come, right? So they just had one task. As soon as the Coke comes in, the payment gateway hits and the payment is sent. And payment, as soon as the payment gets deducted from the wallet, you get a notification. So the whole logic is based on a single functionality, right? Only in these situations. So you shouldn't apply serverless computing to your complete application. That's a bad practice. You know, when you take application into consideration, there are some parts of application which you have to strategically notice where, you know, where you need not host those into containers or on container orchestrators or on VMs, because you don't want that to run 24 hours a day. You only want that to activate when customer wants it, right? For those parts of application, it's always better to choose serverless, because that would overall save the cost drastically, and it's also one of the most efficient way to build applications. Of course, the benefit of serverless architecture is you basically build a serverless architecture using one of the three patterns, right? Either for mobile backend or serverless or microservices. The benefit of serverless architecture is its simplicity and how you can achieve so much using just couple of resources on any cloud. So this is one of the trickiest question, because people think, you know, if it's serverless, which means you know, there's nothing, there's no, you know, it's completely serverless. No, folks. Eventually, what happens is when you build, you know, when you spin up a VM, right? You select an image, you select a boot disk, you select a RAM, you select everything, and then, you know, you have control over it. And when you and then you deploy it, right? VM keeps running. But as far as serverless is concerned, right, and you are not worrying about whether it has RAM, whether it has running on that OS, nothing. Your core focus is only source code. The complete server management is automatically managed by AWS. That is eventually, see, whatever you do, right, is eventually on a server. But here, you are not managing the server. AWS or any cloud vendors are managing the server. You have to just write a source code, make it error-free, compile it, put it into a serverless architecture, attach it with an API gateway, and achieve your desired results. So it's, when I say serverless, it doesn't mean that it doesn't have server in the backend. It has server, but server management is not done by you. You just have to focus on the source code. Not exactly. No, Amazon S3 is not a serverless. Amazon S3 is basically an object storage, right? So there are different types of storage. Block storage is where you install your OS and database. Object storage where you store your files, images, audio files, right? And also host a static website. Amazon S3 is just like a Google Drive that's available on AWS. It's not serverless. The only serverless application that's available is Amazon AWS Lambda, where you just code in supported languages, that is Node.js, Python, and React, and so many other languages, and eventually you basically achieve the desired result. Interesting. So what happens is serverless is a function as a service. What is a function? A function is nothing but an arbitrary code. You just write the code, you put it into a function, and gets executed whenever it is invoked. Either you are manually invoking or it is invoked through an API. You're getting it? That's serverless. PaaS is a platform as a service. So you basically don't worry about the OS or or basically the RAM, the storage, nothing of that. You basically have to just focus on the platform and your code, right? So you can still have some authority or control over the configuration of your servers in PaaS, but in serverless, you're completely not managing it. It's just an arbitrary code that you're writing in a supporting language, and whenever you invoke, the code gets executed and gives you the desired outcome. That's what I've already told, right? Whenever you have single tasks, right, or one-time tasks that has to be done, or something that has to be invoked manually by a customer on any user-facing application, right? Instead of hosting that, instead of hosting the code and VMs in those scenarios, you can basically go ahead with serverless architecture patterns. And there are three important patterns, that is monolithic, single page, and mobile backend, right? Nowadays, all the mobile applications that we use, right, use serverless architecture as the backend, and they're literally reducing the cost by 80%. When it's a data intensive application, when there's a lot of data involved, and there's when there are multiple logics, or there are multiple tasks to be done through a code involved, then we shouldn't use serverless. It's not recommended. It's always better to use containerized orchestrator. Containerized, it's basically always better to use containers or VMs in those scenarios. That's again dependent to an application context. Of course, because it's a flagship product, you basically have to write a small function code and deploy it to AWS Lambda, and it'll take care of everything. And the reason why it's called serverless is you need not worry about server management at all. You just write a code, put it on AWS Lambda. Either you invoke manually or get it invoked through a HTTPS request or through an endpoint of an API. You get the desired outcome, and you can integrate that to any application. Thanks a lot, Shruti, and thanks a lot, Cloud and Cloud fraternity and the whole team. I hope I have been extremely passionate, and I've tried to, cut out all the jargons and explain things in simplicity. If there's any jargons, please excuse me, and you can reach out to me on LinkedIn anytime. Thank you very much for this opportunity.